Hello, welcome back to everyone. See this problem. So this is a problem of resistor circuit. So asking that by using node analysis, how to calculate voltage V0. So first of all, observe the circuit carefully here. So totally here 3 branches are there. So this is one branch, and this is the second branch, and this is the third branch. Okay. Now voltage V0. This is the voltage drop across 4 ohm resistor. This is the V0 value. Now how can you find that V0 value here? And one voltage source given, that is 60 volts. Another is dependent voltage source, that is 5 times of V0 is given here. Now how can you find that V0 value? So first of all, analyze here this branch and this branch and this branch. 3 branches are parallel to each other. So whenever parallel branches are there, so in each branch the voltage drop is same. So let's consider that voltage drop is V1. So this is the voltage drop in this branch, in this branch, in this branch. So higher potential minus lower potential, nothing but this is the voltage drop in this branch. That voltage drop totally happen in every branch because all branches are parallel to each other. That's why I'm going to consider certain value, that is at node V1. Now apply node analysis. So each branch having some current. So sum of all currents from all branches, that's equal to 0. Some are incoming, some are outgoing currents are there. That's why sum of all currents at this node, the overall current equal to 0. Let us assume in this branch the current is I1. In this branch there is a current I2, and here the current is I3. So at this node, sum of all incoming and outgoing means sum of all currents, so which are connected to this node, that will be equal to 0. So that is nothing but I1 plus I2 plus I3, that is equal to 0. So first of all, how to find currents? So by using Ohm's law, we know that V equal to IR. So from this we get current I equal to V by R. So I1 is the current in the first branch. So in this branch the voltage is V1. So in every branch there is voltage V1 is there because all are parallel. So in this voltage is V1 and resistance is 6 plus 4, that is 10 ohms. So voltage by resistance nothing but current, that is I1. Next, current I2. So in this overall branch the voltage is V1 and here certain voltage is there, source is there. So we are going to find the voltage here, that means V1 minus 60. So that is the voltage here by resistance, that is 20. That is the current I2 in this branch. Next, similarly in this branch the current I3. So that is V1 minus the voltage 5 V0 by resistance. So total voltage is V1 in this branch. So in that I am going to remove this voltage. So the remaining voltage drop will take place in that 20 ohms. So that is the voltage drop in 20 ohms by that resistance value gives the current in this branch, that is I3. So the resistance is 20. This is equal to 0. Now take LCM, that is 20. So 2 times, that is 2 V1 plus 1 time, that is V1 minus 60 plus 1 time V1 minus 5 V0. So that's equal to 0. So bring 20 this side and becomes 0. So that is equal to 2V1 plus V1, 3V1, and again 1 is there, that is 4V1. So 4V1 minus 60 minus 5 V0. So but here in this equation 2 variables are there. So one is V1, another V0. So is there any relation for V1 and V0 from the circuit? Yes, possible. Let's see. In the first branch the current I1, so that is equal to total voltage, that is V1 by overall resistance, that is 4 plus 6, 10 ohms. So this is the current in the first branch, we know that. So this is the current passing 4 ohms. Okay. So current I into this resistance gives voltage drop across 4 ohms, that is V1 by 10 into 4, So that is the voltage drop across 4 ohms. That is already given as V0. So that is equal to V0. So from this we get V0 equal to 2 by 5 times of V1. Now replace V0 with 2 by 5 V1. So it becomes 4 V1 minus 60. So minus 5 into, so V0 is 2 by 5 times of V1. So 5 cancel, that's be equal to 0. So 60 becomes this side plus 60, that is 60 equal to 4 V1 and here 2 V1, nothing but 2 V1. So V1 equal to 60 by 2, nothing but 30. So V1 is the 30 volts. But here we want V0 value. We know that V1 V0 relation, substitute this value in this equation, we will get V0 value. So that is V0 equal to 2 by 5 times of V1. V1 is 30. So 5 ones, 5 6, 6 to the 12. So 12 volts is the V0 value. So V0 equal to 12 volts and V1 is the 30 volts. So this is the required value V0, that is 12 volts for the given problem, and this is the process of node analysis. And thanks for watching. Please subscribe, like, share. Thanks.